Welcome back to our research series on human-centric robotics. In this series, we are exploring the uncharted, wild steplands of robotics, where robots are designed to work alongside humans, with humans, and for humans. And in today's episode, I will talk about something very important in terms of defining the types in human-robot interaction. But before that, let me tell you that I am in the third week of August 2025, and I'm coming to you from the Claremore Reserve in Sydney, Australia. So let's get started. Today, unfortunately, I forgot that my stick to hold the camera is broken, so it'll be quite difficult for me to hold the camera properly with a proper angle. But let's see how it goes. So I'll be explaining you the human-robot interactions and a couple of research-oriented groups, main three categories. And these categories are human-robot coexistence, human-robot cooperation, and human-robot collaboration. And today, in today's episode, I will be explaining you the differences between these three groups, and also I will talk about some subtle similarities. And finally, I will conclude the video with the future directions and what is important and where the robotics research is heading towards. As you know, there are three terms in the human-robot interaction. And let me explain each term. You know that human is a human, that's a living organism that has belief, consciousness, and also some sort of irrational behavior. I think that's obvious to talk about human, but also I made a video on who are the humans and what human wants. If you are curious to look at the video, please check out the link up there. It's a mud, actually. I've just got into the mud. But anyway, let me take my bag and come back. Oh, good, not good. But anyway, so the first term is a human, and human is a living creature having an intention, belief, and also consciousness. Also a living creature that does decisions not always rationally. That's a human. The second term in the human-robot interaction is the robot term. And I believe there is a huge amount of confusion nowadays that's been emerging with the term of robot. So that's why I think it's better for me to give the definition clearly. The robot term is derived from this term of Slavic or Czech or Russian language term of roboda, which means working, physical labor, and then the robot is derived from that. It was first used in 1920s. Then in 1941, Isaac Asimov used the robotics term for the first time in his scientific novel called Liar. And after that, it's been used pretty much in industry and in the tools and manufacturing. But the point I'm trying to make here is I'm seeing this terminology is being shifted a little bit, and which I believe is not the way originally the term stands for. So nowadays we're seeing that the robot term is associated with the human-looking mechanical machines, or like robotic arm that has 6 degrees of freedom or 3 degrees of freedom. Thus, robotic arms are associated with being a robot compared to other robots such as that originally don't have any human-looking characteristics. For example, those robots I'm talking about are the vacuum cleaner robot or dishwasher as being a robot, because the definition of robot has 3 elements. It has one element is about sensing the environment, second element is about computing an action, and a third element is doing an action that's external its body. And if you look at a dishwasher or a vacuum cleaner, they have all three elements are satisfied to being a robot. And in 1950s and the rest 1970s, 60s, those dishwasher and vacuum cleaners are still considered to be robots. Unlike nowadays, and most researchers and the field is confused that they are excluded being a robot, which is not true, which is kind of disillusionment and forgetting about the core term definitions. All right, so that's the second term. Then the third term is the interaction. And interaction doesn't have to be physical interaction only. There is mainly two types of interaction. One is the physical interaction, where you can touch, you can move around. And the second interaction type is a communicational interaction. Basically, if a robot is giving feedback or giving a communicative information, visual information, or verbal information, that's still interaction. So we defined all of the three terms in human-robot interaction. Let me talk about the three main types of human-robot interaction. The first type is the coexistence of robots. Second one is the cooperation. And the third one is, which is the most advanced and the newest one, is the collaboration. And I'll give you examples of this, and I will define each of these groups or types of interaction independently, separately, and also discuss subtle similarities and major differences between those. And also talk about why we should make these differences, and why it's important in a research context. And finally, in this video, I will conclude the video with the future directions, where the robotics is heading towards, and why we should care. We should give attention to the terminologies and do not mix those terms. So first one, the basic one, as you know, robot coexisting with humans. It's important that I put dishwasher and similar robots as vacuum cleaners as robotic category, because they are a robotic category of human-robot interaction where they coexist with a human. What does that mean is their actions and their incentives are independent of the human incentives and actions. The second group is the cooperation robots. And the question is, when do robots cooperate with a human? The robot that's a cooperative robot should have a shared goal with a human. One of the examples of the cooperative robots could be the drones. When a pilot operates a drone, a fleet of drones, let's say, and then pilot gives a location where the fleet of drones has to go, that's where the pilot is interacting with the robot in a cooperative manner. Even though it could be sequential actions, the robots cooperating with the humans can do simultaneous actions as well. That's where the confusion in the literature occurs from my research so far, is that the differentiation between the cooperation and collaboration in the robotic case is done basically by the way the actions have been executed. So the collaboration is stated that the actions has to be simultaneously or at the same time in the same space. But actually, if you look at the terminology difference of collaboration, it's not about doing an action at the same time. And it's not about being in the same space. And I will give you an example of those robots. Imagine a robot has a mathematical model and keeping track of human needs, let's say. Then whenever the human needs are not satisfied, the human can give an information regarding those unsatisfactory elements, and then human will adapt to those situations, or make a robot to adapt, or give a command for a robot to adapt. That's where the collaboration occurs, because robot's intention is to be a partner. Robot's intention is not just be a tool, such as in a cooperation case, but the intention is to be a partner and be a teammate and work as a team. So most of the robotics currently we see has been told as human-robot collaboration are robots that do not actually collaborate. They do cooperate with a human. For the robot to collaborate with a human, the robot has to have the advanced level of agentic capabilities or empathic capabilities, so that it will understand the human needs and be more human-centric compared to the robots of cooperation. So if we draw a graph, let's say we draw a graph in an x-axis, we draw a line of robots' agentic capabilities, and in y-axis we draw a volatility of the task, or the level of risk, or the dependency of the task. Then on the left bottom corner, we can state that that's where the coexisting robots take place. And when we go to the highest level, that's where the collaborative robots take place. Meaning that if task volatility, the demand of the task, is really high, it requires higher level of agentic capabilities, which drives robots to be partners, which drives robots to be a teammate and collaborate with a human. So basically, as a concluding point, I want to say here is the difference between collaboration and cooperation is not about their actions being done simultaneously or sequentially, but it's about whether the robot is a tool or a partner, whether the robot is a tool or a teammate. Finally, the research is pushing towards making robots collaborative robots, and I'm seeing huge amount of demand in the field that wants robots to be teammates and partners rather than just being tools in a coordination. Because at the end, we want robots to be adopted not by just innovators and engineers, but adopted by the majority, mostly 80% of the society. You might ask, why then dishwashers has been adopted by the society even though they are not collaborators or cooperating with us, they are just coexisting with us. The reason is that the volatility of the task is low. If the demand of the task is high, the volatility is high, then the agentic capability, empathic capability of the robot should be high to satisfy the demand of the external task-related volatility. While in a dishwasher case, the volatility is quite low. So for a robot to be adopted by the majority of society, the coexistence level of the robot as a capability is enough, because the volatility of the task, the complexity of the task is quite low. And that's all from this video today. And I hope you enjoyed the video, and I see you soon in the next one. Bye for now.